Hello everyone. I am currently, obviously not here, currently at jury duty. Notice on the board there's nothing written in for tomorrow, Thursday, Friday. That is because I do not know whether I will be here tomorrow or Thursday or Friday, depending upon what happens today at jury duty. If I get selected for the jury to go to the case for the rest of the week, then I will not be here. However, if I don't get selected, then I will be here. Hopefully I do not get selected. So plan for today then is to learn a concept called completing the square. The recording will help talk through that process. It is also in the book, section 2.4. If you get stuck, don't understand, you may read the textbook. I will also post this to PowerSchool. And so you can listen to this tonight at your own pace. But the plan for today is to get stuff done, and we are going to learn how to complete the square. Your quizzes will be handed back tomorrow when I get back, and we'll talk to them, etc. If you are wanting a retake, I will give you one extra day. We'll be able to take them on Monday because I am not here today. All right, completing the square. Hopefully you have paper out. If not, you need to get something out to write on. Today will work very similar to what it would work if I was still here. We will talk through concepts. I'll have you do some work. I'll do some work. You do some work, etc. So just because I'm not here doesn't mean things will be any different than if I was here. At some point in time, I'll ask you to pause the recording. Someone can come up and hit pause and then restart it once you're ready. Completing the square. The goal of completing the square is to switch an equation that's written in standard form into vertex form, or to solve. Today we're going to do number 1, and tomorrow we'll do concept number 2, completing the square to solve. So that is our plan. So notice the top is in standard form. The second equation is in vertex form. Our goal is to rewrite something that's in standard form to vertex form. Now, just like factoring, completing the square is going backwards. So before we can go backwards, we have to go forward. So let's look at something that's fairly straightforward and ask ourselves, what does it look like going forward? Come up with a pattern and use that pattern to help us go backwards, just like factoring. Yeah, you really do need to understand the forward process before we can go backwards. Okay? As I go through this, if you cannot write and think at the same time, I know that sounds strange, but if you can't write and think at the same time, don't write. I would rather you think and watch me and kind of predict the next step than to try to frantically take notes. At some point in time, I'll pause and let you take notes. If you can do both, great. All right, so x plus 2 squared. What does squared tell me to do? If I ask you to take 5 squared, what does 5 squared mean? It means 5 times 5. So what does x plus 2 squared mean? It means to multiply x plus 2 times itself. Just like 5 squared does not mean 5 times 2. It means 5 times 5. X plus 2 squared means x plus 2 times x plus 2. Just like when we started factoring, we need to learn how to FOIL this out or remember how to FOIL this out. X times x is x squared. X times 2, 2x. 2 times x, 2x. 2 times 2 is 4. Combining like terms gives me x squared plus 4x plus 4. Not going to draw a conclusion yet. Let's do another one. What if I gave you x minus 3 squared? Let's go ahead and multiply that out. Again, if you can stay with me or actually go ahead of me, you keep going. If you just want to watch or think through with me, that's fine too. At the end, I'll ask you a question. X times x, x squared, minus 3x, minus 3x, plus 9. Hopefully, we've done that enough that that's not an issue. Combine like terms, x squared plus 6x plus 9. So there's going forward. The goal today is to come up with a pattern that will find what's called a perfect square. This and this is considered a perfect square because it will break down or it will factor into two terms that multiply together that are exactly the same. Just like 25 is a perfect square because it breaks into 5 times 5. This expression is a perfect square because it breaks into x plus 2 times x plus 2. And this is a perfect square for the same reason. So how do we find or make a perfect square? I'm going to give you a question. What if I asked you x squared plus 10x, and I put something there, or asked you to put something there to make it a perfect square? What number would you put right here to make it a perfect square? Look at what just happened there. There is a relationship between this number and this number. What is that relationship? There is a relationship between this number and this number. What is that relationship? Think about it for a second. Where did those different numbers come from? And see if you can figure out what you would put right here. Make a guess. Even if you're wrong, make a guess. What number do you think goes there? Okay, hopefully you have a number. Let's check that number. It really, really is important that you make a guess. Okay, think about the pattern. See something. Even if it's wrong, you will learn from being wrong. You might even learn more from being wrong because then you can adjust your thinking. Don't wait for me to say the number. Don't wait for me to explain the pattern. What number do you think goes right here so that this will break down into two parentheses that are exactly the same? Okay, we ready? First question. Where did this plus 4, I know we have a lot of boxes and arrows and stuff here, but where did this plus 4 right here come from? It came from multiplying this 2 times this 2. Where did this 9 come from? It came from multiplying this 3 times this 3. Notice I circled the sign also. So where did this 10 come from? It came from adding these, let's go backwards. Where did this 4x come from? It came from adding these two x's together. Where did the negative 6x come from? It came from adding these negative 3x's together. Using that logic, there must have been two numbers that we added together to get 10x. And those two numbers must be the same two numbers. 5x and 5x. So that 10x came from adding 5x and 5x together. Again, we're thinking backwards. Well then, how does this 2 give me that 4? Where did that 2 come from? Let me erase some of these things so you can see what I'm looking at here. Let me erase all these different arrows. Okay? So where did this 2x and this 2x come from? When I multiplied the inside and the outside together, I got the 2x and the 2x. Well, this times this gives me the 4. Notice that this 2 and that 2 are the same. So the 5 and the 5 give me this number right here of 25. Okay? If I were to factor the x squared plus 10x plus 25, what would that factor into? Well, let's just factor it. Go back to last week. What two numbers multiply together to give me x squared? X and x. What two numbers that are the same? Because remember what we said, we're looking for a perfect square. What is a perfect square? Remember I had the 25 over here? Why is 25 a perfect square? Because it factors into two numbers that are exactly the same. Why is 49 a perfect square? Because it factors into two numbers that are exactly the same. So, what two numbers that are exactly the same multiply together to give me 25? Okay? Don't jump to the answer. Make sure you understand my questions and the thought process you should be thinking about. We get 5 and 5. How do I get a positive 10x? From a positive 5 plus another 5x, and that's where we get this middle piece. All right. Notice the number that we put right here. Where did that come from? Notice the relationship between the 25 and the 10. Where did the 10 come from? It came from two of these terms added together. So my first step to figure out what number I have to add, I divide the coefficient of x by 2. That was big. Did everyone hear that? To figure out what number I have to add, my first step is to divide the coefficient of x by 2. Why? Because the coefficient of x came from two terms being added together. To find out those two terms, I divide the coefficient of x by 2. Next step. What did we do to get the last term? We multiplied that number we just found by itself. We squared it. So my first step is to divide by 2. My second step is to square it, and that is the number I plug in right there. I'll give you another one. What if I gave you x squared minus 14x plus something? What would you add to make that a perfect square? Now, you should have a guess. You may not have last time, but now you should have a number that you would put there. Have a number before I tell you the right answer. First step. Take the negative 14, divide it by 2. I get a negative 7. And square it. A negative 7 squared is a positive 49. Notice, it does not matter whether this middle term is a positive or if this middle term is a negative. You will always be adding. Okay? Why? Because a negative squared is a positive, and a positive squared is a positive. The steps. Divide the the coefficient of x by 2 and square it. What does this factor into? X squared factors into x and x. 49. Factors of 49. 1 and 49. 7 and 7. I want to pick the two numbers that are exactly the same. The middle term, the coefficient of x, is negative, so both of these must be negative. When you get to this point, your two factors must be the same. Otherwise, you did not generate a perfect square. Now, how can I rewrite x minus 7 times x minus 7? X minus 7 squared. Just like before, if I wrote 5 times 5, another way of writing that is 5 squared. All right, that is the steps for completing the square, basically. Let's put it all together. Let's start with something in standard form now. Now that you know how to make a perfect square, let's switch from standard form to vertex form. That is our main goal for today. So y equals x squared plus 8x minus 9. There is our standard form. I want to convert that into vertex form. Okay? First question, is that a perfect square? No. Hopefully we said no. Why? Because this 9 is not 8 divided by 2 squared. Right? If it was a perfect square, then the relationship between the coefficient of x and this number over here, called the constant, has to be this here. It's not. So it's not a perfect square. And here comes the name completing the square. We are going to complete the square. We are going to make it a perfect square. It's not now, but we want to do something so that it is. So what do we have to do? First step, get rid of that negative 9 because it's not the right number. Well, I can't really get rid of it, so I'm just going to move it. I'm going to temporarily get rid of it. It's not the right number, so I'm just going to move it out to the side and deal with it later. Now, let's make this parentheses piece a perfect square. So what do you want to add right here in this blank to make it a perfect square? Well, we already did that once up here on the board. We take 8 divided by 2, which is 4, and we square it, and that's what goes here. We now have a perfect square. I can't just add 16 to an equation, right? That doesn't make sense. I can't just add 16. So if I added 16 to the equation, what would happen if I subtracted 16? What did I really do to that equation if I add 16 and then take away 16? Nothing. I technically added 0. If you add 0 to a number, did you change the value of the number? No. So I really added 0, or I did nothing to change the value or the validity. Big word. The validity means, is this statement true? Still? Yes. I added 0 to it, and adding 0 to something doesn't change it. So the point is, why did I add 16 and just take it away again? So I can change forms and not change the validity of the statement. Y still really does equal that equation. I haven't changed it at all. I just changed what it looks like. All right, what does the x squared plus 8x plus 16 factor into? Factors of x, x, and x. Again, factors of 16, going back to last week. 1 and 16, 2 and 8, 4 and 4. I want the two numbers that are exactly the same, the 4 and 4. I want this sign in between there. On the outside, negative 9, negative 16 is a negative 25. Rewrite this, and I get y equals x plus 4 parentheses squared. Why? Because there's two of them. And when I have two things that are exactly the same being multiplied together, another way of writing that is squared. And you got it. Completing the square. Get rid of the term that is not making it a perfect square. Move that out. Add something to make it a perfect square and write it in vertex form or factor it. Okay? Let's try another one. Okay? Now, in your groups, give it a try. Someone come up and push pause. When the groups are all done, all ready to go, then you can go back and push play, and get it to play again, and I'll talk through the answers. Should take a couple minutes. So someone come up and push pause, and we'll get going. Okay, hopefully you are back. I'm assuming you had a chance to work through this. Again, hopefully if you were stuck in your groups, you were talking amongst your groups to figure this out. First step, take that 17, which is not the right number, and move it out. Second step, figure out what I have to add to make this a perfect square. So I divide the 12 by 2, and I square it. Remember, it's always addition, even though it's a negative 12. Because a negative 6 times a negative 6 is a positive 36. Okay, I just added 36. I can't just add 36. So I'm going to subtract 36. Added 36 inside, subtract 36 outside. I did nothing except for change forms. Okay, factor. This factors into x minus 6 times x minus 6. Positive 17, negative 36 is a negative 19. Rewriting it in the correct notation gives me that. You now can look at that equation written in vertex form and find the vertex. You could not do that in standard form, but now we've converted from standard to vertex, and now you can see the vertex. You should be able to see the vertex is 6, negative 19. You should be able to see the axis of symmetry is x equals 6. You should be able to see that the range is y is greater than or equal to a negative 19. The maximum, the minimum is y equals negative 19 or negative 19. You now can answer a lot of questions when it's in vertex form. Okay? Now, some of you are going to say, we already could do vertex form using negative b over 2a. You are correct. And if you want, you can double check, do negative b over 2a, and you should get the same answer. But sometimes it's nice to have multiple techniques because sometimes one technique is more valuable for certain kinds of problems than another technique. You will have to know how to complete the square later this year, and especially when you get to pre-calculus and we start talking about conic sections, things called hyperbolas and ellipses and things like that. Completing the square is a technique you must know how to do. Okay? And we're going to generate the quadratic formula, which is the most powerful of all the solving techniques, tomorrow by completing the square. So you have to know how to complete the square. Okay, plus one of the standards is completing the square. Let me give you another one. In your groups, give this one a try. Last one, and then I'll jump to the last most difficult way of, or form that you'll see for completing the square. All right, give it a try. Again, come push pause. When you're done, come back and push play. All right. I assume you've had a chance to check that one out. I will go a little faster now. First step, move the 5 out. Second step, figure out what we have to add to make it a perfect square. Divide the coefficient of x by 2 and square it. Oh, sorry, I didn't actually square it. Old habit. Okay? If I add 25 inside, I must subtract 25 outside to make it have no net result, meaning to balance the equation. Finally, factor. And we get x plus 5 squared minus 30. If you want to go from here to here, that's great. Skipping this step of x plus 5 times x plus 5. You can do that. I do that Don't do that, though, unless you understand where this x plus 5 squared comes from. Make sure you recognize that it really comes from just simply factoring. No special technique there, just simply factoring it and rewriting it into another form. Okay? But it is a very acceptable and appropriate step to skip this middle one here. The more you practice, the more you realize, oh yeah, I can skip that. All right. Hopefully the basic complete the square is okay. Let's go a little harder. Let me see how long this thing has been taking. All right. You are probably about 35, 40 minutes into class. Let me show you one. With a coefficient of x squared that's not 1. Y equals 2x squared plus 12x plus 17. Notice the first few problems, the coefficient of x squared, this guy right here, has been 1. Now it's not. Now it's a little harder. Not much, don't make it too hard, but it is a little harder. First step. Same. That 17 is not the right number, move it out. Next step. I cannot complete the square until the coefficient of x squared is 1. It's not. It's a 2. So let's make it a 1. We are going to divide every term inside of the parenthesis by 2. We are going to factor that 2 out. 2 goes out here. When I divide 2x squared by 2, I get x squared. When I divide 12 by 2, I get 6x and a parenthesis. We are going to divide by whatever is in front of the x squared. It's not always 2. It is 2 in this case because the coefficient of x squared is 2. If the coefficient of x squared had been 7, I still must divide by 7, even though it's going to make a mess. I have to divide or factor out whatever is in front of the x squared. I'll keep it nice and neat for a while, but at some point in time you will have to deal with a fraction. Okay, complete the square. Ignore the 2 for a second. What do I have to add? Looking at just this piece, what do I have to add to make that a perfect square? I divide 6 by 2 and I square it. However, that 9 is inside of a parenthesis that has a 2 touching it. When that 2 is touching that parenthesis, what does that tell you to do? It tells you to multiply that 2 times everything that's inside. And when you do that, you should be going backwards, back up to what you had in the line above it. So if we did that, we'd multiply 2 times x squared and get 2x squared, just like we have right here. We would multiply 2 times 6x and we get 12x. We would multiply 2 times 9 and we would get 18. We didn't add 9 to this equation. We added 18 to this equation. So in order to balance this, I need to subtract 18 from this equation. Because that 9 is inside of a parenthesis being multiplied by 2, the net result is not adding 9. It's adding 18. So to balance the equation, I must subtract 18. Now I can factor. Leave the 2 alone. X squared plus 6x plus 9 factors into x plus 3 times x plus 3. Positive 17, negative 18 is a negative 1. Rewrite it in the other form. X plus 3 times x plus 3 is x plus 3 squared. Again, going from here to here is totally fine. Okay? There's vertex form. Excuse me. Okay? All right, I know the hour is probably about over. I think we have time for another one. You have to try one on your own or in your group. try this one. Y equals 3x squared plus 24x plus 32. Complete the square. Someone come up and hit pause in your groups. Give it a try. When you think you're all done, come back up and push play and hear the result. Go. Okay. First step. I'm going to, I won't skip a step. First step, get that 32 out of here. It's not the right number. Second step, divide everything inside the parentheses by 3. Third step, figure out what you have to add in this blank to make it a perfect square. Divide 8 by 2 and square it. We okay so far? Get rid of the 32 because it's not a perfect square. Make the coefficient of x squared 1, so I divide everything, or I factor out everything. Factor 3 out of everything. Why 3? Because it's the coefficient of x squared. Third step, figure out what has to be added. I divide the 8 by 2 and square it. Most common mistake is forgetting to divide the coefficient of x by whatever's in front of x squared and have a 24 sitting right here. That is not the right thing. Make sure you divide every term inside of the parentheses by the coefficient of x squared. Next step, that 16 that I just added is being multiplied by 3. So what I really just added to this is 48. 3 times 16. To balance the equation, I need to subtract 48. So we added 48, we subtracted 48. Net result, we added 0. Factor. This factors into x plus 4 times x plus 4. Outside becomes what? Negative 16. Rewrite it into the correct form, and you have Vertex form. Okay. Again, let me check how long we've been. You are probably getting very close to the end of the hour. I think I will stop. And there are 4 problems on the board. Try them. There's 2 review of factoring from 2.3. There's 2 complete the squares from section 2.4. Tomorrow, first thing, hopefully I'm here, but first thing we'll talk about is what happens if you have a negative in front. We'll talk about that tomorrow, and then we'll complete the square to solve. So if you have a few minutes left in class, utilize them. Don't just sit and do nothing. If you are really struggling and you get home tonight and like to try some problems, you can try the problems. Check or go back and watch the recording again, and that may help. Okay. Again, good luck. Hopefully I see you tomorrow. Have a good night.